Hey, what's going on, folks? It's Mike here, and welcome to the Programming Language First Impression series, the series in which we look at a programming language for the first time for about an hour or so, and just see how it is to get started and to use that programming language. Now, today we're going to be using a programming language that's quite old. It's 66 plus years old. But interestingly, I want to go ahead and show you on the Toby index for, again, whatever this index is worth. It's not perfect, but you'll see that this programming language, well, can you see it? Can you guess it? It is, in fact, Fortran. And the Fortran programming language is what we're looking at today. And again, despite its age being 60 plus, maybe almost 70 years old at this point, it is, well, still one of the top programming languages. And it has its sort of niche, as I understand it, in scientific computing. But I really have not written a Fortran program. So we're going to go ahead and change that today. And let's go ahead and see how the Fortran language stacks up against some of the other languages that we've seen here. So let's go ahead and start with the wiki here, and then we'll go ahead and get Fortran set up here. I don't know the official websites, but I see a lot of great YouTube videos here and so on. Looks like there are some other introductions here. I'm going to assume it's this Fortran Lang page here. Again, I don't always get it right here, but I think that looks like a reasonable website here for learning and checking out Fortran here. It looks like there's a discourse and all sorts of cool stuff here. But before we get to that, let's go ahead and start with some of the history here on the Wikipedia page talking about Fortran. Again, what's kind of interesting about Fortran is, again, its age and that it's still used. So this would be sort of one of the older programming languages probably in existence that's still very, very active these days. Again, let's see. First appeared 1957. So yeah, we're getting close to 70 years old in 2024. What is that? Yeah, 67 years. They've done the math for us here. So quite impressive. And again, it is a multi-paradigm language with structured programming and an imperative, even generic. And I suppose there are some object-oriented features as well. I wonder why these are in parentheses, maybe because you have to implement them, but we'll find out. But interesting to see that there was a stable release just a few months ago, 3 months ago since this video is being recorded here. And then we'll just note that we use the .f extension here. And it's a statically typed language here with strong typing. So again, if you're coming from a C++ background or D or whatever, you're sort of used to that sort of development here. So anyways, a little bit about the history here. It says Fortran was originally developed by IBM. So again, IBM was sort of the superpower in computing for those who don't know, into the 40s, 50s, 60s, 70s, until companies like Apple and Microsoft eventually sort of moved in and took over their domain in desktop computing. And of course, IBM today is still a huge company doing all sorts of things as well. But let's see, it compiled correctly in 1958. Interesting. So they must have started development, maybe took a few years or so. And as this wiki's showing here, and again, if you know general purpose language, you can do anything, but it looks like Fortran has really taken its niche in scientific computing. Again, that's as I understand it today as well. So it's a standardized language, and it looks like there's been various ANSI standards of the language. So 66, Fortran 77, Fortran 95, and Fortran 2008, which adds concurrent programming. Fortran added in 2003 object-oriented programming. So it looks like it's really gone through an evolution. I'm really curious to see the features of this language here. And of course, the wiki's got the TOB index here mentioned. So yeah, it's still holding its place in the top 15 languages. Again, the TOB index isn't perfect for those who know about it. It's some measure of popularity. So it's some metric. So interestingly, I just want to back here. John Backus was the designer of Fortran. I remember this because in my high school days, I had to choose a scientist to do a book report on. And my teacher's criteria at the time, my science teacher, freshman year's criteria was you couldn't do Albert Einstein or Marie Curie because those are the two that everybody would just pick. So she'd get, 20 or 30 reports on the same two scientists, and that was boring. So she said, choose somebody else. And that was enough to sort of make students choose something interesting. So for myself, I was getting interested in computer programming around that time in high school or towards the end of my middle school. And I wrote it about John Backus in the Backus Noir format here. So kind of interesting to read about him. Yeah, the BNF format here. So, kind of interesting history. 1977 Turing Award winner. I'm sure some of those contributions with Fortran as well as other things were, paramount here. So kind of interesting here to learn about Bacchus and again some of the history here along with the languages. And interestingly, he's done some other functional programming stuff here, and of course is a winner of many awards here, it looks like. So quite a career here. Attended many universities, it looks like. Well, he's the one who brought us Fortran. So anyways, just wanted to share that story, which I thought was interesting. It might be interesting for those of you who have children, if you get maybe you can encourage them to do some lesser known scientists. Your John Bacchus, Francis Allen, Grace Hopper, these types of figures, Susan Eggert, all sorts of interesting people that you could probably think of here. But anyways, let's go ahead and kind of keep going through here. Learning about the from the Wikipedia about Fortran here. Let's see. He's got an interesting quote here while we're on Bacchus here. It says, "Much of my work has come from being lazy." I've always sort of heard this from programmers. Right, a good programmer is sufficiently lazy, meaning you should be automating, some of your work here. So he says, "I didn't like writing programs, and so when I was working on the IBM 707, writing programs for computing missile trajectories, I started work on programming system to make it easier to write programs." Yeah, I mean, we always try to write, programs to make our life easy, I suppose here. And of course, the early computing applications were things like rockets and these sorts of things here. Okay, so that's what he's referring to. I guess he was working at various places on there. Let's see what else we got here. 1960. Let's see. Just kind of looking through here. Fortran. Okay, we're getting a little bit into the syntax here. The original one, let's see, 32 statements. Okay, all caps here. We're going to have to see if our caps lock button works on this keyboard. I haven't disabled it on my Vim quite yet. I still press escape or the JK sometimes to go to normal mode for my Vim users on this channel. Let's see. Okay, so I mean, it's got all the basics. I mean, what's sort of interesting just looking at this list initially, these are the things you'd expect to have in a standard library as far as function calls for a few of these things, like working with files and so on. And of course, you've got your basic conditional statements, go to as well, which is fun. These all effectively look like the things you also find in your system calls. Read, write. Of course, they've got write tape, write drum. Like old style memory here. Anyways, we're going to see how this has changed here. And a punch card. Again, I'm not old enough to give punch card stories. I never really used them. Have seen them, and, folks I know have used them. I have some myself. So this is kind of interesting, punching in the opcodes, I suppose, for every command that's going to be run one at a time here. We live in a pretty good time as far as programming goes. So interesting just to see some of the history. This is kind of cool stuff. Again, you can see this Wikipedia is massive, so maybe we're not going to go into it and just go into the language here a little bit. But it is still interesting to know a little bit about the history of these languages. So if you get to go to a computing museum and stuff, you can kind of appreciate and have some context for these languages and what they looked at. For those who make it to California, or if you're ever in London, there's different, computing museums that you can see, around the world. And wherever your home is, maybe there's one nearby where you can see some Fortran punch cards. So anyways, just kind of scrolling through this. It's interesting to see all the different features coming along. But this also, before we go into the language, I just want to comment, as we see Fortran 95, and then what did we have, 2003 here? It's sort of inevitable that, and folks sort of complain about the complexity of languages that they grow. If your language isn't growing and it's just sort of not doing anything, it's whether that's the standard library or the language itself, you're kind of in a stagnant phase. And maybe that's fine, but it is interesting to see that languages that tend to grow in popularity tend to grow in their feature sets. That's what we've kind of seen with a lot of different languages, getting new features or their standard library grows. The Go language, which is the most popular. I don't know if you caught that in the Toby index for February of 2024. That's a small language, but it still gets some features, over time. So languages are growing. Maybe it's every 8 years, like for Fortran, or every 10, or whatever the cadence is. But languages do change and grow over time. So yeah, it looks like every 5, 8, or 10 years or so, you get a new Fortran standard here. Kind of interesting. Yeah, there's a lot of interop with C here. Okay, and there is Fortran 2023, so maybe we'll run into some other features here. And they've really done a nice job here showing off some cool pictures of the scientific computing being done here in Fortran. So yeah, very neat here. Very neat. Okay, we got to see this. Humor. Okay, this is the first time we've stumbled upon this. And let's see here. What's the joke here? Okay, they're going to name it Fortran 77 was chosen. A satirical technical proposal was incorporated into the official distribution bearing the title letter O considered harmful. Ha ha ha. Okay. For those who don't know, there's a famous paper by Dijkstra called Go To Considered Harmful, which I think was written in maybe 67 or maybe it was around this time. I don't know exactly. Maybe it was a little bit later, if my memory is correct. But let's see. The proposal was to eliminate the letter character set entirely. Oh, that's funny. I wonder if it's because, the O and the null, like 0, just kind of look the same. That is kind of funny. Anyways, all right. A little bit of humor. Let's get out of here. I promised I'd get to the web page, and let's write some Fortran code today. All right, so let's take a look at the website, kind of get an idea of the community. Again, I love seeing newsletters on programming language web pages. I don't know why, if it's just something that I was used to, but it seems like a nice way to kind of, if you're active in the language, to get like little updates that are consumable. Right, I can't handle, a Twitter feed, every day or whatever, or X or whatever. Meaning, like, it's nice to have an archive of these, even if they're just release notes. But these are nice things. You can highlight what's going on in the community. Looks like there's a package manager here. That's kind of cool. Yeah, this is kind of nice here. Nice regular cadence here. So I like seeing these things here, just exploring around. Let's see what's going on in Fortran news. So you got your newsletters. I wonder if there's like a Fortran conference or something. Always kind of useful to know about. Yeah, it looks like they just have their newsletters. And some folks are maintaining that, which is really neat. Nice effort there. Okay, well, let's see. The features. High performance. Yeah, this is, if you're going to be doing scientific computing, you need a performant computer to do a lot of computations and so on. So again, that makes sense for the compiler. Static typing. Again, this is sort of a to have a highly performant language, oftentimes that goes hand in hand with static types. Knowing what your data type is going to be, the size, these types of things, you can optimize a little bit without having to at runtime do any introspection. So again, those things tend to go hand in hand here. And again, these days, I would say in this decade, static and strongly typed languages are much more in favor. Again, for this reason, for performance and safety, which goes sort of hand in hand. Let's see, Fortran's relatively easy to use and learn because it's a small language. Okay, we'll put that to the test. But I believe it. I believe it, right? There's a reason Fortran is still taught and used in schools and, again, in industry. Many of you, I suspect, if you have engineering backgrounds, meaning like non-software engineer, I should say, engineering, like if you're doing mechanical engineering or these types of things, it was very common in various universities that I saw that you would learn Fortran as part of that. Let's see, multiple paradigm and natively parallel. This is the big thing here. It's got the array-like syntax. So it's an array-based language. We were just looking at Odin recently, which again had a lot of these array-based style of computations that you could do here. So I'm interested to see here what that looks like. Maybe we'll get to explore a little bit here and learn some new things. So it's saying you could run almost the same code on a single CPU or a shared memory multi-core system or on a distributed HPC or cloud-based system. So that seems like a pretty nice sales pitch if you're writing code for scalability here. So what's the state of Fortran? Yeah, it's mature for sure, 67 years old, still under development. Again, nice to see here. The GNU compilers, I know mine comes with Fortran, or I can compile with Fortran front end, so that's nice to see. Let's see, Fortran's used for the best supercomputers in the world. Let's see the top 500. We haven't looked at this. Lists, let's see. I don't know what kind of code they're writing. Let's see who's in first place right now. The Frontier, okay, in the U.S. at Oak Ridge National Laboratory. That's a lot of cores. Okay. Okay, this is pretty impressive here. I guess the most cores wins here, although this is pretty impressive, the Eagle here. Let's see, that's at Microsoft. Interesting. Okay, good job, Microsoft and Intel and of course the government labs. Let's see, Fujitsu in Japan, Finland. Yeah, some cool stuff here. Leonardo. That's kind of interesting. Okay, and yeah, let's see. They've actually got a way to write proposals. Again, we've looked at this just a tiny bit. For folks who are really interested, and again, you're probably watching this series if you're interested, knowing about how languages develop, there's usually committees that meet, you write proposals, discuss the proposal, and agree, oftentimes with the standards committee, and which usually consists of folks who implement the compilers and so on, about what language features you'll actually be adding here. So this is just, again, some nice stuff to see advertised here. And as far as tools, looks like there's a nice ecosystem here. Again, I wasn't expecting a package manager. This website, let's see here, I guess has some more tools here. I would expect there to be like linters and these types of things as well. But they've got this pretty organized. I mean, they've made Fortran stand out as a modern language. Just things like having a package manager. What a big sell these days, at least for getting into the language. It's nice to be able to get something up and running. In practice, if you have a company or maybe you're doing something, maybe you're writing or, very careful about your dependencies that you're installing. But again, it's nice to be able to use other folks' work, the open source work there. Okay, so we should get started, though, learning here. And again, as mentioned, there's a pretty active community here, Discourse, Twitter, and so on. Alrighty, so yeah, we are new to Fortran. Looks like there's a playground, though. Let's keep that as a backup in case we have trouble getting things installed. And this is nice here, mini books. I like this, best practices. That is something, I suppose you'd assume for most languages they would write their documentation using the best practices, but again, it's sort of nice here. And this is kind of nice here. I mean, maybe Python with NumPy is the competition, but they've got sort of the how to translate one thing to another. I mean, that's kind of nice regardless. Having these, here's how you do it in one language, but here's how you do it in this language. That's useful for the adoption of the language itself. So I think that's kind of nice. And this is something I love here, building programs. We might keep that up here. But it's actually teaching or talking about what it means to compile software. This is huge here, actually, the documentation. Good job, fortranlang.org, for having this to talk about. Oh, they're even talking about linking. I love it. My most popular video on YouTube at this time is talking about compilation because I don't think it gets taught enough. I teach it, but it remains a mystery, and it's becoming even more and more a mystery these days to folks. So again, that's why I'm an advocate here for teaching these things. So this is pretty cool. They're even introducing Make. That's cool. Or build tool and how to distribute your programs. Talking about different things. This is a really nice guide here. So good job, Fortran. But anyways, let's go ahead and get started. Let's do the quick start tutorial and run some things here. Get some basic concepts. Okay, we got to get Fortran installed here. I've got my terminal, so I'll be ready. Let's see. I don't think I have Fortran, but we could probably install it. Let's see. It says to use our package manager here, and there are binaries available. And if you watch I have some more videos on compiling GCC, for instance. You could specify your front ends. So I have not done that, especially since I've just upgraded to Ubuntu 22. Let's see here. Let's see if this is a nice, easy install for us. If we have Fortran, Okay, perfect. Okay, so again, love languages that just work when you install them, but that's why it's good to have the web backup in the playground. So that's even cool to see. Otherwise, we'd have to go to Compiler Explorer or something. There's probably Fortran there. But yeah, let's write a hello world here. Let's use tmux, and I'll split my window here. Hello, and then they're giving us the extension f.90. Okay, I guess that's the version here. G Fortran. What is my version? Version 11 here. So I don't know if that's Fortran like 2023 or what it is, but it doesn't really matter. I'm just going to use F here. Let's write a program. Program, hello, a comment, exclamation mark, okay. This is a comment, and print, let's see, star, colon, or comma, single quote, hello world, then end program. Okay, so I actually like this here because my end program matches, the program that I'm ending. So that's actually kind of nice. It helps kind of line things up, I imagine, if you have the indentation. Let's save that. Let's actually move hello.f to hello.f90. Let's see. Does Vim give us... there. Now we do get the syntax highlighting. Okay. Great. Okay, so let's try to run this and compile it. Right, we skipped the compilation guide, but generally speaking, we're going to pass in our source file. Hello f90. Okay. The output of our binary. Okay, so this is basically matching everything that we do in this series here. So that's pretty familiar to us. And then if we run this, oops, PROG, hello world. Okay, very nice. Okay, so what did we do here? We ran our first program, and then they're going to introduce some more data to us. Okay, I wonder why it gave us this space. I wonder if the asterisk is just like a, well, I don't know, something interesting. But already interestingly, we can notice there's no like parentheses around this, so it's pretty concise. The keywords in the language here, you can have spaces in between them. I mean, so this reminds me almost of BASIC that I was doing a long time ago, when things like Dark Basic and Blitz Basic and these types of things. And what I could say here is, it makes things kind of readable, but this is also just maybe an artifact of the style in the, well, when this was invented, the 50s or the 60s, to make something readable, kind of basic and useful. I could see why it got very popular, right, versus using machine code, right, that maybe this translates very well here. I need to think about how we parse this. But let's go ahead and look at variables for storage. Okay, we got some built-in types. Already noticing complex because this is a scientific language. So again, for a lot of engineering applications, we need to use complex numbers. So, some of my graphics folks or maybe my electrical engineers, of course, know about this. Real numbers for floating point, integers, character, and logical. Okay, interesting. So for our Boolean values, true or false. So again, all this is looking pretty reasonable. All right, so again, statically typed language. So we have to use our variables or declare our variables before we use them. And let's see what we've got here. Okay, so variable type is the one we'd like to use, and then the name here. Okay, interesting. So space, colon, colon. I wonder if those spaces matter. Variable name is to start with a letter. It consists of letters, numbers, and underscores. Okay, so let's go ahead and try this. Now, what does implicit mean here? Fortran code is case insensitive. You don't have to worry about the capitalization of your variable name, so it's a good idea to keep it consistent. Okay. Note the additional statement at the beginning of the program. Okay, implicit none. This statement tells the compiler that all variables will be explicitly declared. Without this statement, variables will be implicitly typed according to the letter they begin with. Oh, interesting. Okay. That's a style that I use. Sometimes I'll prefix in languages like C a pointer with P for the variable name, or I. Not so much with the type, I suppose, but sometimes the context, like if it's static or a pointer, we'll begin with a S before a static variable or a P. So that's kind of interesting. Let's follow that convention. Implicit none. Create some variables. Integer, amount, real. Okay, we'll do pi. I wonder if we have a const value here. Frequency, character. Now, character, it would be nice to abbreviate that to char. Maybe there's a way to do that. Is okay. Okay, so let's go ahead and compile. and run Fortran. Okay, still running. No weird errors or anything. I wonder if this actually gets compiled. Now we have to kind of, here, let's, I'm just sort of curious here if this is available on Godbolt. So let me just copy this. There must be Fortran on here. As far as languages, let's go ahead here. Fortran. Yes. Just kind of interested in what the actual assembly looks like and if there are optimization levels. Does this match GCC-O of like 3 or something? This program doesn't really do anything. Okay, so it is able to, get rid of variables and not generate code that we don't use. So pretty smart compiler there. That's kind of neat. And overall, the assembly is, pretty much matching what we'd expect here. Now, print is doing some interesting stuff here. But this looks like, oh, okay, it is calling some function, maybe that's part of, I wonder if this is part of like the standard library. Let's look at, I guess I could use LDD here and see. We are linking in libg Fortran here, okay, which might have some function calls and stuff. I was gonna say this would have been really interesting. I was trying to figure out how low level Fortran is if it was able to just omit the assembly or something for print. But yeah, overall, it's nice sometimes when the languages match closely to the assembly. So again, this is a performance language. So anyways, we've gone a little bit away from our variable assignment, but that's what we've got there. Let's see here. Watch out for assignment at declaration. Okay, this is not a normal initialization. It implies the save attribute, which means that the variable retains its value between procedural calls. So interesting. Good practice is to initialize your variable separately to their declaration. Okay, so that's kind of interesting. So I guess if it implies the save attribute, that means it's basically like a static variable in a C function call, what we might think about. So mount will retain its value every time you call that function call. Okay, that's interesting. So that's splitting up the declaration from the where you actually, I suppose, define it or initialize your variable. Okay, interesting. Very interesting idea there. I wonder, I need to think about that. I mean, I'm just wondering about that from the compiler standpoint, what that means. That's an interesting way to get rid of or eliminate a keyword, though. To say, okay, if this is initialized, then every time you call a function, it'll retain whatever its value is. That is kind of interesting. I suppose what that means, I mean, that sort of means, right, if I have this program or this sort of context, and I initialize it and I say, something like amount equals 1, when I am parsing this program, it would make sense for me to just kind of look at this, as a compiler and say, okay, I'm going to store this in the static storage part of the executable, right? And we'll have exactly one copy of it because I am initializing it. It's a known value here. Now I wonder if I print out the amount here. Otherwise, if it does have a default initialization, though, that's kind of a idea here. Let's see. Let's print out some of these values. Okay, we got to figure out what this star comma means here, too. And then we can read the values as well. Okay, so yeah, let's go ahead and try some of these. Here, we know about this. Let's go ahead and print. Oh, please enter your age. And then we're going to read a value here. Okay, age. Okay, this is a little bit funny syntax, but we got to see what's going on. Your age is. All right. And let's give ourselves the age variable here. I wonder if I get rid of those spaces, if that matters here. Let's go ahead and compile and run it. I guess it doesn't. I guess the spaces don't matter here, but it's good style. So here we go. My age, 77 years old. Okay. Or, oh, we missed a chance. 67, like Fortran. Okay. Okay, neat here. The indentation's a little bit weird here. Please enter your age. Okay, read, and then the next line, your age. I guess that's what the print is doing. We haven't explained that to the. Well, let's just do a example here. Let's see if I just put this here. Your age is... Are those just empty lines? Expected comma in IO list. Okay, so those aren't just meaningless placeholders. Maybe we'll learn what print does later on. Unless I skipped it already. Let's see here. Print. Okay. Nope, I guess it didn't explain, but we will see eventually. Okay, but we learned about variables, some standard input and output. Okay, we printed our text out. Again, the standard output or std out. Okay, nice again to have these words. You know, sometimes this will get skipped in a intro to programming book. I don't know. I just don't see a lot of intro to programming books that are even telling you this is standard output. It'll just say print to terminal, but these are important terms to know. So again, just look at this guide. A nice job. Okay, so this is what we've done here. In read here. Okay. I wonder if these are the arguments or something to read, because we are seeing parentheses here for standard in. Interesting. Okay. Let's see. Okay, so expressions. The exponent, 2 star asterisks, like in Python and some other languages. Okay, no problem there. Okay, let's do something here with a couple more values here. Now let's see. Can I just declare values wherever I want? Maybe not. Unexpected data statement here. So let's see. Is it like Pascal? Yes. Okay, so we got to declare variables at the top of our program. No problem with that. I actually like that. I think it makes it easier to gain context. Again, I don't know if that's an unpopular opinion, but I tend to... That's one thing I really liked about Pascal when I remember first looking at that language, I don't know, 15, 16 years ago. I thought it was really nice that, again, it just seemed organized, right? It gave you structure in your program. You know, and you could do that in any language that you want, but it's nice to actually... I like having that sort of restriction here. So anyways, we'll go ahead. Let's go ahead and work with pi here. Let's write a scientific program here. And I have to define what pi is here. 3.1415927. Okay. I can always remember the first 4 digits, but that's about it. Print. Okay. Enter cylinder base radius. And we're going to read the value of radius. Okay, and again, we need to include radius here. And then let's go ahead and print that out. Pi times, let's see, pi times radius squared here. Yep. For the area. Let's see here. Oh, okay, I see they're just storing it in a separate variable called area. It is nice not having to type out semicolons all over the place here. Let's see here. Can I do this? Comma volume. Let's see if it complains at us. And check out some of the, error messages here. I didn't enter the cylinder height. Okay, so let's also do that here. I could do it in a little bit of a different order. Just see what's going on. Alright, here's our program. Alright, let's see if it screams at us for doing like this initialized list thing here. Might not like that. Oh, I don't have height here. So here, we can do it again. Okay. Radius is just spelled wrong. Raid, like an attack, I suppose. Or the bug spray. Okay, that does work. Okay, so I bet there is some proposal at some point, but that's kind of nice here. You have all your reals. Again, little things like this, little quality of life things. I just like it because when I read the code later, I know exactly what the type is here. Now, I wonder if in languages, I wonder if Fortran would have trouble with something like auto. Like, I wonder if there's type inference in Fortran. Maybe somebody can comment below about that. meaning that if you have all your declarations about your variables at the top here, I wonder if that would make it like a 2-pass compiler and really slow down things, because you'd have to look and see what variable you have, make sure it exists, and then I guess do the inference, and then I guess we'd have to think about that. Update your symbol table. I guess you'd just take the first value that you see as the type for something. So that's kind of just interesting idea. Okay, so we're still entering our age here, our base, radius, and our height, 10. And then we did not print out the area or the volume here. Area, and print the volume. And again, we want to make these kind of interesting here. Area and the volume. Okay, let's go ahead and try that out here. Compile. Age 5, because I know what 5 squared is, and 10. Okay, so 5, so 25 roughly times pi. Yeah, that gives us about 78. And then, times another 10 for the height. Okay, so our program works. We can verify math is correct. That's pretty nice here. Okay, let's see here. Oh, no, interesting. It looks like you can specify the precision. I mean, since most machine architectures are going to have different floating points, 32, 64, maybe 128, etc., it makes sense that you can actually have a little bit more precision here. I wonder, that must be true with the integer types as well. So anyways, that's kind of nice here. Okay, let's see. Local scope variables with block construct. Okay, so as soon as 2008 here. Okay, so we're able to have blocks here, and then I can declare more variables and then reuse the names here. Okay, that's reasonable enough. Block and block. Yeah, that's kind of nice. Or scope and scope, I suppose here would be another way to call this. Right, rather than using curly braces. That's the same idea in other programming languages. Okay, not too bad here. All right, let's see. Arrays and strings here. Let's see. The integer type and then the dimension. Okay, interesting. And here's an equivalent way here. Okay, you could just say array here. Array 2 with 10. Okay, so they introduced a shorthand. One of the first programming languages that I learned is Dark Basic, and yeah, for an arrays you would just type dim in for the dimension. And I don't know when exactly I made that connection that was an array, or dim was short for dimension. So actually, as a beginner, it might have been nice to see that typed out many times. But it's funny to have that memory and kind of click after all these years. But yeah, that's what you've got, the dimensions. I don't know, since an array is a contiguous block of memory, I wonder why we don't just say like block of 10 or something. That was another thing well into, Dark Basic of how would we call like a mem block or something. There was sort of a similar concept to that. Let's see here. Oh, interesting. You have custom lower and upper index bounds here. So it doesn't have to be 0 base. That's kind of interesting. I mean, maybe it just fits problems better, or if you're loading a piece of data that's been exported, again, that makes sense. I mean, it kind of makes sense if you have like a graph or something, which again, for scientific computing, it is kind of nice to have negative indexes. If you think about these like axes and a Cartesian coordinates or something, that's totally reasonable. So very nice stuff here. We've got array slicing. Okay, that's great. I can't really live well in languages that don't have this anymore. I got too used to it in the D programming language. And it's just really nice to be able to just grab a slice or get a view into an array. Is another way to think of it. Right, in C++, you have views and spans, I guess, as ways to access things. But slices are really nice and convenient here. Yeah, let's go ahead and try out one of these here. Let's go ahead and just comment out this program. Now, I don't know how to do multi-line comments yet, so we got to do this here. But we'll keep our code. Actually, we don't need to keep our code. It's all in the tutorial. Let's just get on with it. Let's create an integer called values, and I guess we could do that for a shorthand, or we could type it out as dimensions. But let's go ahead. I like this shorthand. That's reasonable enough here. And then we'll go ahead and print the array, the index here. Okay, print out elements. Oh, okay, since we're doing from odd, I guess they're 0 based by default from 10, and then every 2 elements here. Let's see what they're initialized as. Okay, syntax error here. Oh, I called this values. Okay, and it's printing out, yeah, garbage in memory. Okay, so another optimized language. Nothing's initialized here for us by default. So reasonable enough here. Okay, and it looks like for working with slices with 2D arrays, you could just leave the first value empty here. Okay, so very, very clean syntax. Again, something that can be learned from. I wonder when this was added into the language or if it's always been there, because that's pretty convenient. If this was something that was part of Fortran early on, Fortran 77 or early, you know, bravo to them for being sort of ahead of the game. Now, we haven't looked at like Lisp and some other pretty old languages as well. Maybe they've had these features as well for a long time. Of course, we looked at Clojure, but I can't quite remember if it had this similar syntax at this point in time. Okay, dynamic arrays. Okay, allocatable. Interesting. Okay, so yeah, these have been static or fixed size arrays. And looks like we use this keyword allocatable here once we know, or when we don't know how big the array is going to be. So for a single dimension, you just put colon, and for two-dimensional array, colon, comma, colon here. And then you could actually just allocate here. Okay, so very nice. And deallocate. Okay, so those are your maybe better words than malloc and free, telling exactly what you're doing, allocating storage. So I like this program. Very, very nicely written here. I wonder what allocate is sort of implemented as. Meaning when a lot of these high performance language, the big thing is having custom allocators and sort of control or region-based allocators or otherwise like arena-based allocators. So I wonder, again, how this is sort of being done here. But yeah, it looks pretty cool. Looks clean enough. And notice one thing I'll say is, right, in C++ we have delete and delete with the brackets to delete an array. Notice that deallocate just does the right thing here, which is kind of nice. It doesn't appear to be any special syntax here. Because again, now I guess we would look at having a heap allocated. Let's think about that. If we just have a single variable or something that we've heap allocated. Again, maybe we'll have to look at the object-oriented stuff for Fortran, but yeah, this is pretty reasonable here. Let's see, for strings. Okay, looks like you just create a array here. Len equals 4. Okay, so it looks like a property or something of the character types. They can again just create the array here. String concatenation. Okay, this is kind of interesting. Let's type out some of these here just so we continue making some progress here. And let's try this out. Character len equals 4, which happens to be how long Mike is. That's why they wrote this here. So the first name equals Mike. And let's go ahead and let's do the last name as well. Last name. And we're still a length of 4. Last name. We got to get to function calls, I guess, because I want to see, again, if I initialize that here, that means it's always the value here. And we have full name here. Character. Now, I guess we should try that with allocatable here, right? If I want to just be able to store this, let's actually do that. Let's jump the gun just a little bit here. So I don't know the size. I'm going to say this is allocatable. And then that's the full name. Let's see if that works. Oops, I snuck in a semicolon here. Full name equals, let's see, first name // a space in between, and then last name. Oh, I see. This is just the escape characters or something to insert this character. Or maybe that's the case here. Okay, does that work? That works. Okay, let's print it out. Full name. Okay, that works. Okay, fair enough. I forgot something. Deallocate. There we go. Full name. Don't want any memory leaks. Wonder if this runs with Valgrind. Okay, there we go. Arrays of strings. Okay, getting into some more interesting things here. Let's see. An array of strings can be expressed as an array of character variables. What I'm just looking at here is to see, okay, keys, user, and DB name, and then we've got the values. Oh, I thought for a second this was going to be like a map data structure here, but it looks like we're just storing that in two separate things here. But we do have our first subroutine, our first function here. So doing some more interesting stuff here. And show. Okay, that's the name of this function here that's being called. And what are we doing here? Okay, our declaration again. Oh, interesting. Character. The intent. Okay, what's this here? Okay, and then we're doing trim here with a loop. Okay, so they jammed a bunch of things in here. So we got our first function call. And again, we've got that same pattern, subroutine and subroutine. Show here. Okay, so kind of interesting here. And trim's going to get rid of the spaces in our keys. No problem there. That seems reasonable. Okay, so anyways, I mean, this is pretty reasonable. Like, the syntax, I'm overall... There's a few rules and things to get used to, I suppose. I got to figure out what's this contains thing. Okay, so they've kind of thrown a few different things here. Maybe this subroutine is part of this program. Maybe that's how that works there. So that's like the scope or something, or again, just adding structure into our actual program. Maybe that's how we set this up here. I'll have to think a little bit about that. That's kind of interesting. It is very structured code. This is very readable code, I will say, though. Again, I think that helps by having the structure of the declarations, the logic, and then maybe like the member functions or the methods of this program or something. That's what it kind of looks like here. I bet when we go to organizing code structure, it'll tell us. Let's just do a quick look through here. Interesting, they got the alternatives for these symbols. I actually kind of like that. I wonder if there are cases where that's more readable, or maybe if you're generating code, maybe there's some advantage to this. I'm actually curious as to the reason why this is being done. Why would you have an alternate symbol? Because then you're mixing. It makes, I mean, why have two things for the same job here? Sort of an interesting question. I wonder if this is like the function call equivalent or something. I'll have to think about that here. Again, probably need to read the history of the programming language a little bit more to understand if this is just what you had on like a teletype, like the printer. That could be, and maybe this is like the new modern, we got more symbols and you actually had something, more characters. I mean, it's kind of interesting, right? If you're designing a programming language for a phone or something, you probably just want whatever shows up on the first keyboard string without having to hit shift or hold keys or, press a lot of characters. I'm not sure if we're going to, in this series, look at APL and some of these other languages that have a lot of characters. But, let me know in the comments if that's interesting, because that's what I'm suspecting this comes from. But again, I don't have any idea. And then, okay, we have the logical. Now for the operators, they're all like and or. Okay, maybe it just reads better. So we have if, then. Okay, so very basic. Like, I wonder how much basic programming languages were based off of Fortran back in the day, like QBasic. We looked at FreeBasic on this channel previously, which was based off of QBasic. We looked at Pascal, so you have that sort of if-then setup here. So kind of interesting to see here. Now let's see, if we've just got one statement here, no like begin or end blocks or anything, I guess it just knows. Let's see here. Yeah, I want to see if there's something more complicated. Oh, then you have to do your end do. Okay, yeah. Yeah, in the basic programming language days, I would just use end for everything, but this is telling which one you're ending, which is kind of, yeah, it makes the parsing easy, I suppose. You can just kind of count how many things you're in. So again, something interesting to think about here. Do loops and so on. Okay, I mean, okay, now let's get into, I was going to say we should jump ahead because we're almost at the hour mark, or getting to that point here and see some of the cool stuff here. This is cool here. Now this is popping up here. Do concurrent, okay? Let's go ahead and let's just try this out here. Let's just do a copy, good old fashioned copy and paste, and see what happens here. This little program here. Let's see here. Set, paste. And try to parse it out here. Doesn't look like the indentation matters, which is kind of nice. Here, let's indent this though. Oh, it's giving me some errors. Maybe? Okay. Well, let's just run it here. Okay, so it is running. Let's just take a look at the code here in our output. I wonder why it's giving me trouble here. Ah, that's okay. We'll just ignore the no highlight. Oh well. But okay, let's see here. Real. Okay, so we got our parameters here for pi. Another parameter here that we're setting up here. Oh, are we computing sine here? Okay. Careful, the syntax is slightly different. Okay. Do concurrent for I from 1 to n. N is 10 here. And then we compute our result. Let's go ahead and indent that just a little bit here. For result underscore sine here. So this is just storing the real value here for n here. Oh, that's just creating an array with 10 values. Okay. Then we just compute the sine values, okay, of I times, yeah, pi divided by 4. Now it's got a period at the end. I'm assuming that's to indicate that's a real value versus an integer, right? So that we get the proper type of division here. Then we print out our array here. Okay, pretty reasonable here. And notice that, you know, if I'm just able to print out an array, it is just passing in the value, right? I don't have to do a loop or anything. So that's kind of nice that that's built in, because, you know, that could simplify a lot of our code, our logging code. It encourages me to do this type of print debugging or within GDB, which I wonder, can I just do -G here? Yes, it looks like I can. And Fortran, I imagine, is just going to integrate beautifully within GDB. You know, you can check out my GDB courses here, but this is kind of cool here. Yeah, then I can just run this program here. Okay, so I like that. Fortran is integrated into, you know, all the tools that I already know. GDB here. So that's kind of cool here. Do concurrent. That's all there is to it. Built in. I don't think I linked in any. I mean, maybe behind the scenes, the compiler linked in some stuff, some sort of library here. So this informs the compiler that it might use parallelizable or SIMD to speed up execution of the loop, and conveys the programmer intention more clearly. Yes, I do agree with that. D's got .parallel, so I really like that, part of their standard library. Function call this do concurrent is really nice. I think we saw some of these things like in Odin, these like attributes that were also very nice. So cool. I wanted to get to at least one parallel component, and nice that they're showing that early on. Let's kind of run through this. Yeah, let's see. We got our subroutines, functions. Okay, so typically subroutines are things that don't return a value. They just, you know, do some work. And then functions will return a value. You have to say call and then the function. Okay, reasonable enough. That's what we're doing in the assembly. For this one, let's see. Your result here, I guess you're capturing or something. Yeah, after the function. Okay, pretty clean here. I actually kind of like that. You just, you know, you have the result that you're going to store in whatever the type is, and then you just point it out here. I wonder if you could put that in the, I mean, just put that directly in this initialization list. Maybe there's a way to do that. That would also be kind of clean, just thinking from a design standpoint. Let's see here. Okay, Fortran looks like it has a module statement, and then you can use that module here. Okay, so you write this up with your routines. Again, this is pretty, since Fortran is a relatively, you know, clean language. Again, it's got a history certainly of how it was developed. I imagine this code all compiles very fast. It's got a nice module system. It seems to be generating really nice performant code. I'm quite surprised with Fortran. I can't believe I haven't written other programs with it. It seems to be doing a nice job here. And then you've got a way to create different types here. Okay, so these are like structs in C or C++. So very nice here. Very cool. Okay, and then you can do some other cool stuff here. These attributes. Okay, what's an attribute list? Okay, you can decide if it's public or private. Bind C. Okay, so you could interrupt with a C programming language. And you could extend. Okay, it looks like you do like object-oriented stuff at this point. Okay, that's getting us ready here. Okay, so some pretty cool stuff here. Let's see here. Let's see. Matches the following C struct here. Okay, so this here. Oh, I see. Yeah. So this is just to achieve compatibility between C. Okay, fair enough. Yeah, this is interesting. I mean, since so many operating systems libraries are written in C, you pretty much always have to talk to the C programming language for that reason. Again, the good thing is C is a pretty simple language. Fortran looks like it's a pretty simple language, but very powerful again, but meaning that you can kind of learn and understand or translate this to this here without too much trouble here. So the Fortran type here, you're saying, hey, I want to bind this to C. And then I guess C underscore int. Okay, that's something that you're bringing in some module here. And only, that one type here so that you have the effectively can talk to C code. Okay, very nice. Let's zoom through this. Okay, so they're creating a more interesting module here with some types and maybe extending some other types here, which is effectively inheritance, I'm assuming. Okay, so this just gets into like the object-oriented stuff. Okay. All right, so there's some gotchas here. I'm going to kind of move this. Yeah, the implied save, which they mentioned about, like our static. Leading space in prints. Aha, okay, maybe they finally explain this. With the asterisks, I guess that's the whole point of this. Very nice, okay. And then file name extensions. Oh, interesting. Yeah, that is going to maybe cause a problem with .f here. For the legacy source form. Okay, so we should use like F90 or whatever. But okay, important thing to note here, just as we're kind of wrapping up here. Let me move out of the way. The F90 extension that we're using doesn't necessarily mean that we're stuck to Fortran 90. It means all these versions here. Okay. Free form of Fortran here. Okay, so you can use whatever version you want. Yeah, that makes sense. Okay. All right, so nice. Let's just do another kind of quick look around here. Again, I like this building programs. We've got the best practices here on modules, writing programs. It looks like it's really easy to get into writing, some scientific software into Fortran. I could imagine myself building a library for various math things that I do in computer graphics in Fortran with C interop. It seems pretty clean and maintainable, which is really nice. Again, I don't know what it is. These sort of very structured programming languages like Fortran and Pascal and Free Pascal. I just really enjoy having that structure in the language. It just makes things readable. So overall, I'm quite impressed here. Let's go back to the main website here as we wrap things up. And I'll be curious what you folks think about Fortran, what software you're using. I wonder if there's a showcase. There's a community here. Maybe there's something on the discourse or something that we could just see some of the programs. I mean, we saw a little bit of the on the Wikipedia page, some of the different screenshots and so on of different projects. But I'd be curious about very notable Fortran projects. It's always nice to know some of the software that's been developed. It's just kind of neat. And as mentioned, there's tons and tons and tons of courses on Fortran here. I know it's taught widely. Probably any major university has a course on this, right, in their engineering department, if not the computer science department. So it's nice to see all these different resources here. I'm sure there's tons of YouTube stuff, tons of books, recent books. Interesting, even seeing some stuff in quantum. I mean, I wonder if languages like Fortran, again, we haven't done any quantum stuff in this series, are going to be sort of the model for that type of computation. And to see that the claim is that it just sort of works on a single core machine or multi-core machine is really cool. I mean, that's really a testament to the design of both the compilers and maybe the simplicity of the language and keeping that under control here. So overall, folks, I enjoyed learning and looking at Fortran. After 67 years, I have finally dove in. Although it's well older than me, it is kind of nice to look at the Fortran programming language for the first time and follow up on my book report on from John Backus here and see what the creator has done here. Because last time I looked at it from the perspective of, oh yeah, this really old language with punch cards, but can't be more wrong. Fortran is a nice modern language, surprisingly very clean. Again, it'd be always interesting to look at some more of these programs at scale to see how they're developed, but it seems to have a really nice module system, and I like the structure of it. And again, seeing that there's some ease in getting performance with the concurrency built in. And it seemed to say that there was SIMD parallelism that you could get, as well as maybe thread-based parallelism. So I wonder if it like chooses. I mean, there's a lot to learn there on the performance side. That should certainly be interesting. So it seems like Fortran might be a really interesting programming language for folks to learn. It is popular. I do see job advertisements for Fortran, again, especially if you're looking in the scientific domain. If you're not purely just developing like software in the sense of if you're in a specific domain like that's computational, like physics or chemistry, astronomy, etc., I can imagine a lot of that software in that world is Fortran, and this is like totally normal to you. So anyways, it's fun for me to branch out a little bit, and hope you got to enjoy this a little bit on the Fortran programming language. So with that said, folks, thank you as always for your time and attention. I'll look forward to your comments below to hear about software that's been developed in Fortran, how you've used it, how does the language scale. Overall, I enjoyed it. I hope you enjoyed this, but I'd love to hear from you, your takes on Fortran as well. All right, folks, with that said, we'll see you in the next one.